It's update time for Volatus again. There has been a lot of functionality finished in the last week or so. So, one of the things I've been finishing is more. Oh, that's the wrong one. This guy is more of the no-code GUI functionality. No code is of course a lie. The code exists just somewhere else. But the nice thing is all of this is just configured via its descriptions. If you haven't seen any of the previous Volatus updates, this is where it links to a specific behavior implementation, configuring like what channel values that are getting published as telemetry it subscribes to, and also how it sends commands if it's a control, what kind of display formats, colors, how long it takes to show the stale data indicator status, all that fun stuff. And then, of course, no code here. So I can run this, and right off the bat, we're going to see everything with a cyan coloring or outline, signifying that we're not getting live data for these values at the moment. Ignore these errors. I got to clean these up. These are fake errors because it's the way the registration works. They're making sure they're subscribed to the telemetry, but one of the other controls is already subscribed, so I got to make these not be errors, but that's all right. So this is one of the applications that's running. I can then run this other one, and this is the one that generates all of the data. So it's got an analog output task that's running, a digital output task that's running, and an analog input task that's running. And of note is the 16 analog input channels are acquiring at 50 kilohertz in 500 sample chunks, which means that they're getting updated and published out on the network at 100 hertz. And then the digital outputs and analog outputs update on demand anytime there's a value change, but then they also publish at least 10 hertz. In general, all of these GUIs are updating at about 10 hertz. This GUI is probably updating at about 100 hertz. And when I'm not moving windows around, it's sitting around 2% CPU usage. I don't have a dedicated GUI control for this yet, but I can turn on logging. And if we look at one of those debug logs, we can see that it started logging. And eventually I'll have like a status indicator and control for the GUI. So now we're up at about 3% for logging all of that full rate data. Oh, no, just I guess 2.5, 3. Okay, somewhere in the 2 to 3% range. All of that is going to disk right now. And I can stop that and we can take a look. Whole bunch of tests in here. Dear File Explorer, please work. Why is this file with an older date showing up newer? Oh well, don't care about that. And here's the data. So each of these different groups, and there's a fourth one that we don't see a GUI for yet, but they're logging their data. If they do file splits or anything, they'd show up in these folders. But there's all those data. And yeah, analog output didn't really update, so that's pretty small. This one was running at 50 kilohertz for a whole bunch, so that's got to a decent size. And there's valve control, which we'll look at in a minute. So all of these indicators are updating just based on how they're linked in their configuration and what their color is, and they match all of this. Now, these GUIs are kind of the generic test and like system checkout GUIs. So if I wanted to set these all to roughly 2 apart from each other, I could do that. And if I had done this while I was logging, we could open that up in the TDNS viewer and see those changes take place. I can also toggle digital output values manually from here. So these are kind of like these are analogous to max test panels. Not meant to use these directly, but it lets you see everything even if it's not on the GUI. for the DAQmx functionality. But we're going to go ahead and close these guys, or minimize them. And now there was that fourth bit of logs that was getting generated, and that was for some automation control. So something that's going to be common at my job is needing to do valve pulses and kind of, a little bit of a light sequencing and delay work in a very deterministic manner. So there is a timed loop running that can do some of that, and that's all configured here. So there's this valve control module that's been configured to run. It's got 4 different bits of logic that it's running with the configuration that's all in here that link the valves to each other and to the digital outputs that they're controlling. So like latch 1 enable, we can see is this guy here, and there's latch 1 direction, and pulse 1 and pulse 2. And then some default startup values, such as these 0.1s that we can see here in this GUI. So if I toggle latched and we watch these 2 numbers over here, this is going to do a latched valve, which you have to set the polarity of the signal and leave it activated for a certain amount of time, such as 200 milliseconds, to get it to pull in a direction. And then presumably once that actuation time is done, it's in position and will hold itself there even after you cut power. And then you can reverse the polarity and send it the other way. So you might do that with like a double pull, double throw relay to swap the direction. So we're going to open this valve by setting the direction to 1, and then if you looked closely, you could see the latch 1 enable blink at a 1 for about 200 milliseconds. So that makes it easy with just a simple front panel valve control to get that kind of coordinated functionality. And then the other functionality I mentioned was pulsing valves. So right now these are going to pulse only for 0.1 seconds and then turn themselves back off. And that's very repeatable. And then these, I can use these to change the duration. And if we put this back, then the last bit of functionality is sequencing 2 valves with a delay between them. So when I click this, it's going to command the pulse controller to pulse its valve, which it's going to do for 0.1 seconds. Simultaneously, while that's waiting its 100 milliseconds, this sequencer is going to be delaying for 135 milliseconds before it commands the second one. So there should be a little bit of overlap between the two. We're not really going to see that because of the update rates of everything, but we can see it does the pulse 1 and the pulse 2. And if I exaggerate this and reconfigure all of these, now what should happen is this will come on for half a second, and right when this turns off, this will turn on for half a second. And if I set the delay to 1 second, this will turn on for half a second, they'll both be off for half a second, then this will turn on for half a second, because now there's a half a second delay after this one finishes. So just setting it up to be pretty easy for operators to change the parameters they need, and if we need to update these GUI layouts, as long as the values are all configured, that all works great. The nice thing about these automation parameters is they work identical to all of the rest of any other analog output that we would want to control. The same way that the feedback comes back, the same way the telemetry is getting published. So kind of sticking to a couple of base mechanisms so that everything works really well together. And do I have it up? Yes, I've got the telemetry debugger up. And this is some generic tooling that queries the application for what channels it has available, and then it can start receiving it. This only updates about 5 times a second, if I'm not mistaken. But we could see the 2 applications that are running, the DAQ test node and the GUI node. The GUI node has nothing it's publishing, no value it's generating, so there's nothing listed there. And just like the other generic GUIs, we could see all of the analog input tags getting updated. If I go back to the analog outputs window, Why did those not update? Something is broken. Every time. Let me rerun this. There we go. I had left this running between runs of the other application, and some stuff obviously broke. But I can go ahead and start modifying these outputs, and they're reflected here. Likewise, we can watch the telemetry come back on here from the actuations here. But now we can also see the state of some of those control values. And like these pulse durations, if I change these, we can see them reflected. You also might notice briefly this outline that's currently black flashes white. It is white during the time that the command has been sent to the remote module until this telemetry gets published back and matches the commanded value, and then that's when it goes to black. So if things are taking a while to update or there's an error, you'd be able to see that stay white longer. But yeah, so everything's coming together really nice. Getting really excited about how much functionality there's in here. And of course, one of the points of this is to be able to make edits to GUIs really quick. So let's set one of these guys up to demo commanding an analog output. So those values were called test AO0, if I'm not mistaken. Yep, test AO0. So let's update that value, and we'll give it a nice orangey color. C0 8020 sounds good. And now when I run the valve GUI, we've got the nice orange color, and it's stale because the other application's not running. And where's our analog outputs? Put that right there. So now I can be commanding these values going out. And right now, none of this is doing any scaling. There is also scaling configuration that can go in the JSON file. So if this was, like I was setting a set point for an electronic regulator, I wanted 100 psi of gaseous nitrogen out of it. Of course, we could set all the scaling up so that the 4 to 20 signal or the 0 to 10 volt signal or whatever it is that goes out is scaled properly to get that end effect. But right now, everything just has no scaling configured for simplicity. Well, that's a lie. Actually, these are scaled. So the DAQmx task is generating 10 to minus 10, and these have a polynomial configured here. So that is doing some of the, an example of the scaling. And yeah, that's about it. I'm going to be starting to use some of the first test systems are getting deployed this week using this software framework, and of course getting all the functionality in right under the wire, but getting pretty excited about the capabilities of everything here.